Hi, for our senior design project, we're working with Berry Global Erie on a material closed loop process on their production line. I'm Gracie.
I'm Zachary.
I'm Devin. I'm Mike.
So Berry Global Erie is a plastic manufacturing facility that makes closures for the beverage, food, and oil industry. Our project is focusing on their continuous molding machine production lines and improving the inline granulator system that they have on these lines. Currently, scrap starts by entering a bin off of the production line, and then a blower sends that scrap to a hopper. From here, the caps are sent up a conveyor belt and then enter a granulator where they're granulated. A blower then sends this granulated plastic into a hopper, and from here it can go to two locations. Ideally, it would be reintroduced onto the production line. However, if there's too much regrind, it might be sent into overflow and put into storage. From here, it could come back onto the production line, or it might be sold as excess purge blocks. And additionally, if this first hopper gets too full, these caps might be sent to the site grinder. And from here, that would go into the storage and can also come back onto the line or be sold as excess purge blocks. The main objective of our project is to remove the need for the site grinder, storage off of the production line, and the purge blocks. Our goal is to increase the amount of material being used on the production line to 99.3%, which would enhance the waste management system while continuing safety, sustainability, and customer satisfaction for Berry Global. Additionally, our proposed project plan should remain under our budget of $90,000 for the production line.
So we started to work on this by designing and conducting a root cause analysis with 9 total losses that we believed would be the main issues with the system. And off of these 9 losses, we discovered that 3 of them were the main issues with the system. Losses 2, 9, and 1 to be specific. With loss 2, which is scrap sitting as a defect, and loss 9, scrap sitting in storage, are causing 80% of the losses within the current system. And while loss 1, which is the inline granulator equipment being idle, is a large system loss, it's not as important as the other ones, but it still takes up a large chunk at around 15% of the total loss in the system.
For concept generation, we initially generated 12 different concepts. From there, we conducted concept screening, which narrowed our list down to 4 concepts: PLC sensors, self-cleaning mechanisms, smart dashboards, and larger hoppers. We conducted concept scoring with a selection criteria of safety, performance, quality, automation, cost, physical space, and maintenance required. We compared these 4 concepts to the current system and ranked each concept. From here, this resulted in the PLC sensors and larger hoppers ranking the highest, so we decided to combine these concepts and continue with them. Like I said, we decided to combine the PLC sensors and larger hoppers for our final concept selection. This combination will result in increased safety, throughput, available physical space, as well as decreased idle times and maintenance required. Our final cost analysis included costs for equipment, shipping, installation, and material, resulting in a total cost around $52,000.
Once the final concepts were chosen, further analysis was completed to determine other areas of improvements and size requirements. To do this, the team produced a simulation model using Simio. The model was used to find the percent of plastic leaving the production line using different scenarios. After running many experiments, adjusting granulator speed, hopper size, and frequency of color changes, the team generated the results shown in the table below. With the results from the simulation model, we came up with some recommendations for the final project. One additional recommendation was to include a second granulator in the system to keep up with the increased throughput. When implementing a larger hopper and automated sensors, the idle time decreases, which results in more throughput. This may create a new bottleneck at the granulator. Adding another granulator would allow for more scrap to be granulated and utilize the larger hopper more efficiently. The team's second recommendation is to create a structured schedule for emptying the scrap bins. This would allow for the scrap material to keep up with the automated granulator and provide the necessary attention to the sitting material. If the granulator is continuously filled, throughput will increase, and the granulators and hopper will be utilized more efficiently. Another recommendation is to granulate a neutral color in between the color changes, which would reduce the number of times the granulator needs to be cleaned. This will save a lot of time cleaning the granulator, which will allow for more scrap to be granulated. The team determined that these improvements are not necessary in the initial implementation of the project, but are highly recommended to increase throughput in the future.